This last chapter of equivalent figures is optimization of equivalent figures. So what you're going to need to understand before we get introduced to this PowerPoint is that there are several statements about the comparisons, similarities between surface area, perimeter, and volume. And this will help you answer questions dealing with polygons and solids. And that's what we're going to look at in this PowerPoint. So we're going to compare equivalent plane figures, comparing solids with the same surface area, and we're going to compare equivalent solids. So now I'm going to give you some statements. First, about equivalent plane figures. These are statements that I'm going to prove to you and that you are going to need to remember in order to answer certain questions. First, of all equivalent polygons with n sides, the regular polygon has the smallest perimeter. Remembering that equivalent polygons have the same area. And also the star is to tell you that regular polygons have all sides the same length. So if all equivalent polygons with no matter what kind of sides, the regular polygon, the one that has the same side lengths, has the smallest perimeter all the time. Statement number 2, between two equivalent convex polygons, meaning there are no insides, deep corners, the polygon with the greatest number of sides has the smallest perimeter. Statement number 3, of all regular polygons with the same perimeter, the one with the largest area is the one with the largest number of sides. And finally, of all equivalent plane figures, it doesn't matter what, the circle will always have the smallest perimeter. And that's what so this is what we're going to look at. When I give you a bunch of equivalent plane figures, you should know the circle has the smallest perimeter. When I give you a bunch of regular polygons with the same perimeter, the one with the largest area is the one with the largest number of sides, and so on. And again, you're probably thinking, who cares? Why do I need to know this? These are statements that you need to remember when you answer questions when you compare equivalent plane figures. So let me prove some to you. The first statement I told you was, of all equivalent polygons with n sides, the regular polygon has the smallest perimeter. So here's a rectangle and here is a square, and I give you the dimensions. The rectangle doesn't have all the sides the same length. The square, though, it does. It has sides 6 and 6. So if we look at the area of a rectangle is 36 centimeters squared, because we do 9 times 4, and the area of a square is 36 centimeters squared. So they're equivalent, right, because they have the same area. Of all equivalent polygons, the regular one has the smallest perimeter. So let's check out these perimeters. The perimeter of the rectangle is 26 centimeters, whereas the perimeter of a square is 24 centimeters. So notice how two equivalent figures, but the one with the regular sides, the one that's a regular polygon, has the smallest perimeter. So the perimeter of the rectangle polygon here is smaller than the irregular polygon, and it will always be that way. Proving statement number 2, reminding you that it is between two equivalent convex polygons, the polygon with the greatest number of sides has the smallest perimeter. Here's a triangle, here's a rectangle. Triangles have 3 sides, rectangles have 4. Here are some dimensions for your triangle. Here are some dimensions for the rectangle. First, they need to be equivalent. Are they equivalent? I'm telling you that they are. If you do the area of the triangle, base times height divided by 2, you do the area of rectangle, you also get that they're both 8 centimeters squared. So they're equivalent. Now, let's talk about the perimeter. The perimeter of the triangle is 12.94 centimeters, whereas the perimeter of the rectangle is 12 centimeters. Therefore, the perimeter of the rectangle, because it has 4 sides, has the smallest perimeter than the triangle, which only has 3 sides. Statement number 3, to remind you, I said of all regular polygons with the same perimeter, the one with the largest area is the one with the largest number of sides. So it doesn't really deal with equivalence, but it deals with the same perimeter. So here are 3 different polygons, a square, a hexagon, and a circle, and I tell you their side lengths, and I want you to take my word for it. Their perimeter is all the same. So they're all 10 centimeters in perimeter. So the one with the smallest perimeter is the square, which has 4 sides, but the hexagon has 6 sides, which is bigger than the square with 4 sides. But then we have this weird circle. The circle has 7.96 centimeter square area. But we really don't know how many sides it has, so just keep that in mind. Same perimeter, more sides, more area. And just because I wanted to add it here, the circle always has the largest area, always, if it has the same perimeter as another polygon. Here's a question where you might need to know these facts in order to do them. Of all triangles with the same base and perimeter, what is the nature of the triangle with the largest area? Scalene, isosceles, or equilateral? So try it yourself here. Draw one with each the same base and perimeter. Try drawing a triangle that is scalene, a triangle that's isosceles, and a triangle that's equilateral, and tell me which one will have the largest area. It's isosceles. Now that you know the answer to A as isosceles, what is the largest area of a triangle with a 12 centimeter base and a perimeter of 32 centimeters? Knowing now that it's isosceles, you know that two sides need to be the same. You know that the base is 12 centimeters, the perimeter is 32. What is the largest area of that triangle? It's 48 centimeters squared. So now I'm going to give you a worksheet in class to try some practice questions comparing perimeter and area of polygons. This is a good worksheet. It covers the first half of this PowerPoint. Next, we're going to compare solids with the same surface area. Here are some statements. Of all rectangular prisms with the same surface area, the cube has the greatest volume. And of all solids with the same surface area, the sphere has the greatest volume. So the first statement deals with just rectangular prisms, whereas the second statement deals with all solids. Let's prove some to you. Let's prove number 5, saying all rectangular prisms with same surface area, cube has the greatest volume. Here's a rectangular prism, here is a cube, here are some dimensions for you. Let's talk about surface area. Do they have the same surface area? I proved to you that they do. They both have a surface area of 384 centimeters squared. Now, let's talk about volume. I tell you that the cube has the greatest volume. Let's check. The volume of this prism, length times width times height, 281.6 centimeters cubed. The volume of the cubed, sides cubed, so 8 times 8 times 8. Look, it has the greatest volume. Number 6 says of all solid with the same surface area, so any solid with the same surface area, the sphere has the greatest volume. So here's a cube and here's a sphere. And I give you some dimensions of the cube and I tell you that the radius of the sphere is 5.53 centimeters. Let's check if they have the same surface area. They do have the same total surface area. So let's check their volume. The volume seems that the sphere has, yes, of course, the greatest volume. So even though these two solids have the same surface area, the sphere has the greater volume and it will always be the one with the greatest volume when you're comparing all solids with the same surface area. Here's an example of a question that you might have to use these information for. A pear, a banana, and an orange have peels with the same total area. Of these 3 fruits, which one has the greatest volume? The orange, because a sphere has the largest volume of all solids with the same total area. Lastly, we're going to compare equivalent solids. Of all equivalent, meaning same volume, right, of rectangular prisms, the cube has the smallest surface area. And of all equivalent solids, so remember, same volume, the sphere has the smallest surface area. Let's prove number 7. Of all equivalent rectangular prisms, the cube has the smallest surface area. Here's a rectangular prism, and here's a cube, and here are some dimensions for you. Let's check first to see if they're equivalent. If they are equivalent, I did area first, but let's do volume. Volume shows you that they are equivalent. And in terms of the surface area, I show you here that the cube has the smallest surface area from the rectangular prism, and it will always be that way. 2 equivalent solids, so 2 solids that have the same volume, the cube will always have the smallest surface area. Okay, so even though they're equivalent, that's the rule. Number 8 says of all equivalent solids, so any solid, rectangular prism, pyramid, whatever, the sphere has the smallest surface area. So here's a cube and here's a sphere. Here are some dimensions again for you. Let's first, check to see if they have the same volume, meaning are they equivalent? Yes, they are equivalent. Let's check their area. The sphere, sure enough, has the smallest surface area than the cube, and this will be the case for all solids. So even though they both have the same volume, the sphere will always have the smallest surface area with any equivalent figure or any equivalent solid. So here are all the statements you need just to recap. Of all equivalent polygons with n sides, the regular polygon has the smallest perimeter, remembering that a regular polygon has all sides the same length. Between two equivalent convex polygons, this polygon with the greatest number of sides has the smallest perimeter. Of all regular polygons with the same perimeter, the one with the largest area is the one with the largest number of sides. So we saw that the hexagon had a bigger area than the square, but we also saw that the circle will always have the bigger area if the perimeters with the circle is the same. Of all equivalent plane figures, the circle has the smallest perimeter. So of all equivalent, so meaning same area, the circle will have the smallest perimeter. Of all rectangular prisms with the same surface area, the cube has the greatest volume. So we're talking about rectangular prisms here with same surface area. Solids with same surface area will have that the sphere actually has the greatest volume. When we talk about equivalent rectangular prisms, meaning rectangular prisms with the same volume, the cube will always have the smallest surface area. And of all equivalent solids, so any solid that has the same volume as another, the sphere actually will always have the smallest surface area. I'm going to give you a worksheet. You're going to try it, some practice questions on all of these statements that you're going to need to use when you're answering these questions. And that is the end of unit on equivalent figures. And the next one is probability.